So now, before we learnt about the different types of functions that are available for us, now we will look into the different classification of functions, how different functions can be classified into different types. So first we have an onto function, which we also call as the surjective function. What is an onto function? Basically, in simple words, a function which has its range equal to its codomain is an onto function. So simply, in just two words, how you can remember an onto function: any function would be onto if its range is equal to its codomain. Those type of functions, what we call it as an onto function. Now taking an example, let's say if we have f of x is equals to 2x plus 3. So from here, what you can see that the codomain is going to be R. Of course, the set of possible values for this function would be R, all real numbers. So now let us find out the range for this. What would be the range? Either we can do is, we can simply put y is equals to 2x plus 3 and then solve for x, find out the value of y here as we have gotten it, and then check for the domain of y. Here also you can see that the domain of y, there are no restrictions, right? That means my range of y can be from minus infinity to infinity. That means it is the set of real values. So my range also becomes R. Now other way of finding out the range for such type of questions is using the graphical method. If you look at this equation, it is 2x plus 3. What is the standard equation of a straight line? Y is equals to mx plus c, sorry, where c used to be our y-intercept, m used to be our slope, right? So let's say this is my 3 in the y-axis. So my straight line which has slope equals to positive would be this one, right? And this straight line of course extends from minus infinity to plus infinity. Thus our range is basically R, which is set of all real numbers. That is why we call this as an onto function. Now remember this thing, that it is also known as a surjective function. Sometimes in questions they give you either of these two names. They are going to give you either onto function or into function. So you must understand that these two are similar things. Now talking about into functions, what is an into function? Simply explaining to you in two words: any function which has its range as a subset of its codomain would be an into function. So into function, here we have our range as a subset of our codomain, then we call it as an into function. Just remember this thing: if range becomes equal to its codomain, then it is not an into function, then it transforms into an onto function. So here we are not considering the case in which all the values of the set range becomes equal to all the values of codomain, because if that becomes the case, then it becomes our onto function or our surjective function. Now if we were to take an example, e to the power x, what is our codomain? It is going to be R, because the set of possible values can always be R, right? From minus infinity to plus infinity. However, if we look at the range of e to the power x, how does the graph of e to the power x works? It is somewhat in this format, right? Exponentially increased graph. So here you can see that the range is from 0 to infinity. So it is not equal to codomain. However, it is a subset of my codomain. My codomain is R. 0 to infinity is basically a subset of minus infinity to infinity, right? That is why we call this as an into function. Now talking about 1-1 function. 1-1 function is also known as injective function. So one thing that you must not confuse yourself with, onto function is also known as surjective. However, into function is just into function. It is not known as any other name. 1-1 function is known as injective function, and when we will be studying the contrast of this, which is many-1 function, it is not known as anything else. 1-1 is injective. So what do we mean by 1-1 function? This means that for every value of x, there is a different output. For every x, there is a different y. For every x, there is a different y. That means for no value of x, I am going to get two different sorry, for no two different inputs, two different values of x, I'm not going to get a single value of y. So if I was to tell this to you with an example, let's say, so let's say if I take any quadratic equation, for example, this is going to be my graph. So if I look at this value here, let's say this is my x2, and if I look at this value here, this is my x1. So if I look at the projected values of this x1 and x2, it is going to be the same y, right? That means this is not a 1-1 function, because here for two different values of input, two different values of x, I'm getting the same output, right? So this cannot be my 1-1 function. So for 1-1 function, it needs to be just one value. So let's say if I have a function this way, so here you can see for every x I would have a different value. So this one I can say it as 1-1 function or injective function. This is not 1-1 function. So one more thing that you can see is, let's say if I was to show this to you mathematically, let's say if f of x1 is equals to f of x2, that means at two values of x, I'm getting my same value of y. This means if it is a 1-1 function, then x1 would be equal to x2. Because if x1 had not been equal to x2, let's say, and still I'm getting f of x1 equals to f of x2, that means it is not a 1-1 function. It has more values of x for a single value of y. So this is known as a 1-1 function. Now, generally, how do we solve for 1-1 function? Let's say if any question has been given to us. What we do is, we do the horizontal line test. Earlier, when we were studying about, initially when we studied about functions, what we used to do was, we used to do the horizontal line test. Sorry, we used to do the vertical line test for finding out whether for same value of x, am I getting multiple outputs or not. If I was getting multiple outputs, that means it wouldn't be a function. However, here what I'm saying is, if let's say if in my horizontal line test, if I have multiple values of x coming for the same value of y, that means it is not a 1-1 function. So this type of line test is known as horizontal line test. Now a few things that you need to remember, of course. Now this is something that you will learn when you study different chapters. For example, I will teach you one concept of permutation and combination and one topic of application of derivatives in this 1-1 function. So for the time being, you have to remember it. When you study these two chapters, it would become very clear to you how or what exactly are those things. So first of all, as we had studied earlier in this chapter, let's say if I have a set A whose number of elements are m, and I have another set B whose number of elements are n. And what I'm saying is that, let's say if my m is less than n, then what used to be my total number of functions? My total functions used to be equal to n to the power m. I hope you all remember this. I'm mapping A to B. So my total functions that I can map are n to the power m. So this is one thing, I hope you all remember it. Now let's say, what if in the question they tell us you have to find out the number of 1-1 functions that are possible. Now in functions also they've given us a condition that it should be 1-1 function. So total 1-1 functions. How do we find out this value? This is simply npm. Now what is this npm? Now of course n is at the superscript and m is at the subscript. Now this is a very new concept for you, but you will study this when we study permutation and combination. Generally this npm value is written as n factorial upon n minus m whole factorial. Now I hope you all know what factorial is. You have studied factorial in your previous classes. If let's say I'm talking about 3 factorial, so it becomes 3 into 2 into 1. If I'm talking about n factorial, it becomes n into n minus 1 into n minus 2 into n minus 3. And this goes up till into 2 into 1. So that is what my factorial is. So npm is basically this. It is written in this format. So keep this thing in mind. Now this is the case when my n is greater than my m. Now let's say what if, let me write it down here. This is the case when my n is greater than my m. Now what if my m becomes greater than my n? That means the number of values in my set B is more than, the number of values in my set A is more than my values in set B. That means mapping cannot be possible for all, right? So number of functions would simply become 0. I wouldn't have any function possible in that case. Now many to one function. Many to one function is also known as many one function. Again, you can remove the 2 in between, doesn't matter. What happens here is that, now if I take the previous example only, let's say this is my quadratic equation. For 2 values of x, I'm getting the same y, right? For 2 values of x, this is my x2, this is my x1. So this becomes a many one function. Completely the opposite of one function that we studied. So if I were to represent this many one function in mathematical terms, it can be written as f of x1 equals to f of x2 for x1 not equal to x2. If x1 becomes equal to x2, that means I have the same value of x and I'm getting a different value of y. That means it would become a one function, right? However, if x1 is not equal to x2, it becomes a many one function. Now one thing, now I will use a concept of application of derivatives here, that you must remember to solve questions of many one and one functions. How do I check? How to check whether my function is one or not? How to check whether function is one or many one? So there is one way of finding this out. What we simply do is, let's say if we have our function f of x, what we do is, first step is to find f dash x. I hope you all know what f dash x is. Again, this might be a little new term for you because you will study the basics of differentiation in your physics. When you study kinematics there, you will study how distance can be differentiated and derivated to find out your velocity, then it can be differentiated again to find out your acceleration. So for the time being, I hope you all have a little knowledge about f dash x. We find out our f dash x for the function that has been given to us. Once we found out our f dash x, what we do is we check if for any interval f dash x is changing its sign. Check if f dash x is changing its sign. For any interval. Let's say if it changes its sign. If f dash x is changing its sign, that means it is going to be a many one function. So if it changes sign, it is simply a many one function. And if it does not change its sign, it becomes a one function. So I'll write it down here. If does not change sign, then it is a one function. So remember this method for the time being. Let's say you have f of x given to you, find your f dash x, check at what intervals are f dash x changing its sign. If it is not changing its sign in the entire codomain or the entire domain that has been defined there, then we say that it is going to be a one function. And if at certain points the sign is, let's say, negative, and at some points the sign is coming out to be positive, that means it is changing its value. That means we can say it is a many one function. We'll solve a few examples for this. Based on that, it will be completely clear how you can find out your or how you can check whether any function is one or many one. So before we move into our example questions, first let us understand what a bijective function is. Any function which is one as well as onto is known as a bijective function. That means my function should have its codomain equals to its range, and for every value of x I should have a different y. So when do I have a bijective function? For every x we have different y, which means it is a 1-1 function or injective function, and codomain should be equal to the range. Then it becomes an onto function or surjective function, and together these two would make it a bijective function. So keep this thing in mind. Now one more thing that you need to remember about a bijective function is, let's say I have a function y is equals to sine x. Now sometimes what happens is I can find out the inverse as well. How can I write down the inverse of this function? It would become x is equals to sine inverse y. So this is what we call as the inverse of any function. We are simply using the part which was in the domain portion. Now it would become our range, and our range would become our domain. So this is how we write down our inverse function. Now when can we inverse? Whenever our function is a bijective function. So inverse, or let me write it down here. Inverse can only be found when function is bijective. So keep this few properties, few things in mind. Based on these things, we'll solve our questions now. So now let us look at this first question. The function f r, so here we have our domain. This is my domain and this is my codomain. And we've been given a function, so we have to check whether it is injective, surjective or bijective. Here they've mentioned it invertible. Basically what they mean to tell us is whether it is bijective or not. And when does our function become bijective? When it is both 1-1 as well as onto. So first of all, let us check if this function is onto or not. What is our function? F of x is equals to x upon 1 plus x square. So let us check for onto or surjection. So what used to be the condition for onto? My codomain needs to be equal to my range. So what is my codomain here? My codomain in this question is minus half to half. So now let me find out the range for this function. If it becomes equals to this codomain, that means it is a onto function. So again we'll use the tricks that we studied earlier. Y is equals to x upon 1 plus x square. We'll write this equation in terms of y with x being my output, and then I'll check for the domain of y. So here this would become y plus yx square minus x is equals to 0, or this function can be written down in better format as yx square minus x plus y is equals to 0. Now again this has basically become an quadratic equation. So how do I solve my quadratic equation? What I do is I take two cases. Case 1, what used to be my first case, I make the coefficient of x square as 0. So what if I take y is equals to 0? If I take y is equals to 0, what is the value that I'm getting? 0. So I get minus x is equals to 0. That means x is equals to 0. Is x is equals to 0 in my domain? Yes, it is in my domain. That means this is a right value. Y is equals to 0 is in my range. So this is in my range. Now I'll check for the other case where y is not equal to 0. What I'll do is I'll simply make the discriminant greater than equal to 0 so that I can get real roots. If discriminant is greater than equal to 0, that means this would become b square minus 4ac. What is my b? Minus 1 square minus 4 times of a into c greater than equal to 0. So from here I get 1 minus 4y square greater than equal to 0, or this can be written in this format: 2y minus 1, 2y plus 1 less than equals to 0. Now why did I change the inequality? Because I took minus common, I multiplied both sides by minus, and I hope you all know whenever I multiply both sides of my inequality by a minus sign, my sign of inequality changes. So that is what happened here. And if I look at this thing, my number line, here I have minus 1 by 2, here I have plus 1 by 2. This is my plus minus plus, and since it is less than, so that means this is the portion that becomes my answer. So my y belongs from minus half to plus half. Now again, they are in closed brackets because I have an equal to sign as well here. So basically I found out my range. Now I need to include 0 as well. So you can see from minus half to half, my 0 is already getting included in this answer. That means I've found out that my range is equals to my codomain. That means it is an onto function. This function is onto. That means it is a surjective function. First of all, one thing that I found out is it is a surjective function. That means this option is rejected. Here they've told us that it is not surjective. This option is also rejected. Now we need to check for injective function. We have to check for injection or 1-1 function. I hope you all remember the trick that I had told you. If I have f of x is equals to x upon 1 plus x square, what I'll do is I'll find out my f dash x. If I find out my f dash x, what is it coming out to be? I hope you all know in finding out the differentiation, how do we use our quotient rule? Our quotient rule is simply differentiation of first into second function is as it is minus first function as it is, differentiation of second, upon 1 plus x square whole square. So now let me solve this. From here x square and x square would simply just cancel out from 1. So this would become 1 minus x square upon 1 plus x square whole square. So now this is my f dash x. Now I need to check whether it is changing its sign anywhere or not. So first of all, I'll look at the denominator. If I look at the denominator, which is my 1 plus x square whole square, since it is under whole square, this function would always be positive, or it can be 0 as well. However, still I have x square below. That means this is always going to be positive. It is never going to change its sign, whatever be the value of x, right? Anything squared would always give us a positive value, right? And we have a 1 plus to it. That means it cannot be 0 also. It is always going to be a positive value. So for denominator, it's fine. Let's check for numerator. Does our numerator change its value? We have 1 minus x square. What are the times that we are going to get a positive value? When do we get a positive value? We would get a positive value when our x is let's say when our x is less than equal to, when our x belongs from minus 1 to 1, then we would get a positive value. We would get 0 when our x is equals to plus minus 1, and we would get a negative value when our x belongs from minus infinity to minus 1 union 1 to infinity. So I hope you all can see that the numerator is changing its sign as per the domain. Since my domain is R, that means I can put all values from minus infinity to infinity in this function. So if I start putting each and every value, if I start putting the values from minus infinity to minus 1, I would get a negative value. If I start putting the values from minus 1 to 1, I would get a positive value. Then I would get 0. Then I would get again positive values. Then I would again start getting negative values. That means my numerator is changing its sign. So this basically changes its sign. That means if it is changing its sign, that means it is a many one function. It is not a 1-1 function. That means it is not injective. It is not injective function. That means I cannot get a bijective function, of course, from here. So this becomes my answer. It is surjective, but it is not injective. So I hope based on this example, your all doubts about finding out the differentiation and finding out whether it is changing its sign or not have been cleared. Let's look at one more example. Let f be defined from R to R as f of x 2x minus 1, and g is defined from R. 1 is not included in it, and g of x is Now I hope you all can understand why they have removed 1 from the domain, because we have a x minus 1 in the denominator, because if x becomes 1, the entire term would become undefined, right? So we need to find out f of gx. We need to find out things about f of gx. So I hope you all know, if f of x is 2x minus 1, then f of gx, can't I write it as 2 times of gx minus 1? Basically, instead of x, I have to replace gx, right? So now instead of gx, I'll simply replace the value of gx. It would be x minus half upon x minus 1. This is what my f of gx becomes basically. So if I try to simplify this, this would become 2x minus 1 upon x minus 1 minus 1. If I simplify this more, this would become minus x plus 1 minus 1 would cancel out. We would have x upon x minus 1. So this is basically my f of gx. So now I've found out what my this composition function f of gx is. Basically my f of gx is this. Now for this function, I need to check whether it is 1, 1 or onto. So I'll start again with the same things that I did. First I'll check for onto function. My codomain. What has my codomain been provided? For f of x, my codomain is R, and for my g of x, my codomain is R. So simply my codomain would, for this entire composition function, would become R, because I have to take the intersection basically. So if it is R in both cases, my intersection would also be R. Now let me find out the range. So I have y is equals to x upon x minus 1. So this would become xy minus y is equals to x. So from here I can say this would be x into y minus 1 is equals to y. So x becomes y upon y minus 1. So from here, what is my range? That would be, my range would basically be the domain of y. And if you look at y, all values of y are possible except for 1. Y cannot be equal to 1, because if y becomes 1, this entire function would become undefined. So my range is basically r minus 1. So it is not equal to my codomain. That means it is not an onto function. So if it is not onto function, that means this case gets cancelled out, this case gets cancelled out. So I need to check for 1, 1 function now. Let me check whether it is 1, 1 or not. I have my f of g of x. This is equals to x upon x minus 1. So what I'll do is, I'll find out my f dash g of x. What would this become? Differentiation of first into second function as it is, minus second function as it is differentiation of first, upon x minus 1 whole square. If I simplify this, this would become x minus 1 minus x. So this would simply be 1 upon x minus 1 whole square. Sorry, there would be a minus sign here as well. No. So this is the function that I'm getting for f dash x. Now if you look at this f dash g of x, if you look at this carefully, my numerator is always positive. It is a constant value, so it is always positive 1, right? If I look at my denominator, which is x minus 1 whole square. Now anything squared would always be positive, right? Now this is always going to be a positive value. Now I cannot put the value of x as 1. If I put the value of x as 1, it would become 0. However, they have already defined in one of the domains that x is not equal to 1. That means x cannot be equal to 1. I cannot apply this value in my answer, right? So x is not equal to 1. That means it is always going to be positive. That means it is always going to stay positive from minus infinity to infinity. Apart from 1. 1 is not getting included. I'm repeating this thing again. 1 is not getting included. They've already taken it out in the question only. That means for all the domain that has been defined, it is not going to change its sign. It is not changing its sign from positive. That means it is a 1, 1 function. That means 1, 1, it is a 1, 1 function or an injective function. So it is a 1, 1 function but not onto. So this option gets rejected. So I hope you must have understood how we solve questions of 1, 1 and onto function. And these two questions that we just solved, these two questions were asked in previous year JEE mains. So you can see the level of questions that they are asking. Very simple. Just the thing is, you need to have patience and solve them carefully so that you do not make any silly mistakes. Now, one important thing that you must remember, again, there is a concept of some other chapter used here, which is our binomial theorem here. How can you find out the number of onto functions from set A to set B? We've learnt the number of functions that can be defined from set A to set B. It used to be n to the power m. We found out the number of 1, 1 functions. It used to be npm, where n used to be greater than m. If m becomes greater, the number of 1, 1 functions becomes 0. Now, how can we find out the number of onto functions? So there are 3 cases. What I'm assuming here is, instead of m, I'm assuming an r here, because generally whenever we use binomial theorem, we try to use this variable as r. So here, remember one thing, here there is an r here as the superscript of this c. So r, c, let's say we have r, c, k. This is known as a combination formula. And how does this become? This is r factorial upon r minus k factorial into k factorial. So this is just a little different from what we studied earlier. We studied rpk there. Here we are studying rck. So keep this difference in mind. Now let's say if you have number of onto functions, how are you going to find it out? So number of onto functions, considering that I have in my first set n number of elements and in my second set I have r number of elements. Now let's say if my r is greater than n, that means number of elements in my second set is greater than n. So there would be 0 functions possible, 0 onto functions. If r becomes equal to n, then I would have n factorial number of onto functions. And if r is less than n, then I would have number of functions as r to the power n minus rc1, r minus 1 to the power n plus rc2, r minus 2 to the power n, and this would go on up till infinity. Now how can you find out the value of this summation series that you've gotten? We'll study this when we study binomial theorem. For the time being, I would recommend you to just remember this formula and let's move on.